Hi, everybody. Many of the principles in Chapter 9 are the same as in Chapter 8. The difference is we're using a different letter that relies on a different table under a different set of circumstances, but it's all pretty trivial, really. You'd be surprised. The whole idea of hypothesis testing, the 4 steps, the ideas of type 1 and type 2 error, the notion of effect size, it's all the same. So I think you'll really find the reading to be easier once you've gotten past Chapter 8. This is a short extension of that. So here's a research scenario. In studies examining the effect of humor on interpersonal attractions, these authors found that a man's sense of humor had a significant effect on how he was perceived by women. In one part of the study, female college students were given brief descriptions of a potential romantic partner. This fictitious male was described positively as being single, ambitious, and having good job prospects. For one group of participants, the description also said that he had a great sense of humor. For another group, it said that he had no sense of humor, which is kind of a disparagement, I guess. So after reading the description, each participant was asked to rate the attractiveness of that man on a 7-point scale. A score of 4 indicates neutral. The females who read the great sense of humor gave the potential partner an average attractiveness score of 4.53, which was found to be significantly higher than the neutral rating of 4. Those who read the description saying no sense of humor gave the potential partner an average attractiveness rating of 3.3, which was lower than the neutral. Okay, fair enough. So this is where T must be used, and I'll give you an example here. These results clearly indicate that a sense of humor is an important factor in interpersonal attraction, kind of. Much like so many social psychology experiments, I think it's a little oversimplified, but we'll see. You also should recognize that the researchers used hypothesis tests to evaluate the significance of the results. For each group of participants, the null hypothesis would state that humor has no effect on rating of attractiveness, and the average rating should be 4 for each treatment condition, like we did in Chapter 8. Thus, the researchers have a hypothesis and a sample mean for each of the treatment conditions. However, they don't know the population standard deviation. That's the hard thing. And you'll notice that in this particular paragraph, they never gave the population standard deviation. So, thus, the researchers have a hypothesis and a sample mean for each of the treatment conditions, but they don't know the population standard deviation. This value is needed to compute the standard error for the sample mean, which is the denominator of the z-score equation. Recall that the standard error measures how much difference is reasonable to expect between a sample mean and a population mean. And this value is critical for determining whether the sample data are consistent with the null or refute the null, as we remember before. It's almost like going back in time here. Without the standard error, it's impossible to conduct a z-score. Because it's impossible to compute the standard error, a z-score can't be used for this hypothesis test. Excuse me, I dropped my microphone. However, it is possible to estimate the standard error using the sample data. The estimated standard error can then be used to compute a new statistic that's similar to z, and this new statistic is called T, a T statistic, and it can be used to conduct a new kind of hypothesis test. And in this chapter, we'll introduce the T statistic and demonstrate how it's used for hypothesis testing in a situation for which the population standard deviation is unknown. And it's really, that's a huge reason for the existence of Chapter 9. So the value of T obtained and not Z obtained must be used when lowercase s is known and sigma, lowercase sigma, is not known. In Chapter 8, we always knew the population standard deviation, lowercase sigma, and now we don't know it anymore. So the idea is, describe the circumstances in which a T is used for hypothesis testing instead of Z. It's right there in the top. If I have S and I don't have lowercase sigma, I must use T. That's the difference. Explain the relation between the T distribution and the normal distribution. We're going to get to that here shortly. But that's the entire reason for this chapter, and I think you'll find it to be a delightfully short extension with just one extra thing, really, maybe two, like R squared in the definition of a confidence interval.